everyone. Welcome to Microcontrollers and Embedded System Lab. In this video, we shall discuss about the program number 4, that is, write a program to add an array of 16-bit number and store the 32-bit result in internal RAM. Here, we are not using the registers to store the results. Here, we are using internal RAM to store our result. How this is done? Let us go through the program first. This is the program used to add 16-bit numbers and store the value in internal RAM. Okay, array sum is the name of your program. Area is used to declare some area to a particular program. We are writing code here, and again we are using just read only, that is read the memory. Okay, next entry, the program is starting from here. Move r1 5. What is this 5? That means array of elements means we have some number of elements arranged in the form of array. For example, if we consider an array, this array has 5 elements. Okay, this is nothing but the number of elements we are having in our array. Okay, this may have 3 numbers or 4, 5, 6, 7. If we have 7 elements, we can take it as move r1 comma hash 7. Okay, now I am considering 5 elements. Okay, therefore I am moving it as 5. But why in the next step I am subtracting this r1 by 1? That means 5 minus 1. Why I am subtracting this is because we are adding array. Here we have 5 elements, but the number of additions performed only 4, because observe this, we have only 4 addition. Therefore, the counter value has to be 1 less than the total number of array. If we have 6 numbers in my array, then I will have 5 additions. Okay, now I am considering number of elements as 5 and the addition has to be equal to 4 number of additions. Okay, or directly you can copy r1 with 4. Okay, you can skip this step too. If you do that, then we are considering elements is equal to 5, the number of additions is equal to 4. Okay, then I'm storing memory location to register or not. Okay, this is the memory location, which initial address. Okay, we are having an array. In this, number 1 or the first element of this array is stored in this memory location, which is moved to r naught. Okay, then we will go to this memory location and we will feed 1. Okay, we are having 16-bit array addition. 16-bit number means we have to represent 4 number, because each number require 4 bit to represent. Therefore, 4 numbers means it is 16-bit number. Okay, in this memory location we will feed 111, or you can feed any number. Then after that, the number present at the memory location r0, that is, if we are representing just r0, that will be the value, that is 0x4 followed by 7 zeros. If we are representing it with square bracket, that means the number present in this memory location. What will be the number present in this memory location? That will be 1111. Okay, 4 ones will be in the memory location 0x4 followed by 7 zeros. Therefore, after executing this step, r2 will be equal to 1111. Okay, whatever the value you will feed at this memory location, that value will be stored at r2. Okay, after placing r2 is equal to 111, Now I'm adding R0 comma hash 4. Okay, for this address I'm adding plus 4 because we have placed 4 values. After this, the next address will be 0x4 6 zeros followed by 4. Okay, for this memory location I will store another value, that is 222. Okay, whatever you want you can feed that value. Okay, at this location I am storing 22 and 22. The same value will be stored to R3. R3 will be equal to 4 2s. Okay, I am adding R1, sorry, R2 plus R3, which will be equal to 2 plus 1. Okay, after this what I am doing, this is performing first addition. Okay, this has been done, first element and the second element has been added. So next the value of our counter has to be decremented. Okay, we have already R1 is equal to 4. After executing this step, R1 value will be equal to 3. Okay, then it is compared with 0. R1 that is equal to 3. 3 is not equal to 0. Therefore, the loop will be executing again. Okay, now R0 value is equal to 4 6 zeros followed by 4. For that again 4 is added. That will become 4 6 zeros followed with 8. At that memory location I will store value 3 3 3. Okay, after that R3 will be moved with 3 3 and 3 3. Okay, then R2 content will be the sum of previous addition, that is 2 2 2 2 plus 1 1 1 1. For that value we are adding 4 times 3. Okay, the total result will be, this will be stored in this 4 6 will be stored in R2. Again R1 will be subtracted, that is will be equal to 0, sorry 2, and it is compared with 0. Then it is not equal to 0. Again the loop will be executed and plus 4, that is equal to 12. That means that is equal to B in hexadecimal. Okay, sorry, C in hexadecimal. Okay, again for that memory I am giving 4 4 4 and 4. Okay, again here R3 will be replaced with 4 times 4, and for this 4 times 4 will be added, and again it will be decremented. It is compared with 0. That again it is not equal to 0. The loop will be executed one more times. After that the loop will be exited, because after executing the again this R1 becomes 0. Okay, it is compared. Then if R1 is equal to 0, loop is exited. After this the sum is stored in, the overall sum is stored in 42. Now we have to store this sum to our internal memory. Okay, so this is done by passing address to R0 register. This is the address where we are storing our resultant value. Okay, this is an address. To this address we are passing the value R2. Store is an instruction used to copy the value from register to memory location, whereas load is an instruction used to copy from memory location to register. Okay, these are the two instructions used for memory operations, load and store. After this our loop will be our program will be stopped and will come to the end of our program. Something has to be executed in the Kill Microvision software. Initial steps are same: creating a project, all those things. After creating and adding our file to source group, we go for translate, build and rebuild. If there is no error, we will go to debug, start and stop our debug. Okay. In this particular program, before executing the program, we need to do some initialization things. Okay. First, what we have to do is, here we need to create our array first, then we have to add that array and store in our memory location. Okay. We have considered initial address as 4 followed by 7 zeros. At this initial location, we need to store our array. Okay. First, we shall store our first 16-bit number, that is x4 followed by 7 zeros. Okay. At this memory location, I am going to store my first 16-bit number. 16-bit numbers means again 4 numbers, because one number require 4 bits to represent it. Okay. I am adding to this memory location, I am feeding my 16-bit number. Okay. This need not to be 4 ones. You can feed any 16-bit number you required. Okay. After that, next memory location will be 4 followed by 6 zeros, 4. Okay. At this memory location, I am going to add my second 16-bit element. Okay. Then plus 4, that will be equal to 8. At this memory location, I am going to add my third 16-bit element. Okay. 8 plus 4 is 12, which is equal to C in hexadecimal. Here I am going to add my fourth 16-bit number. Then C, that is 12 plus 4 is equal to 16, which is equal to 10 in hexadecimal, where I am adding my last or fifth 16-bit element. Okay. Now I have my array, which is equal to 4 ones, 4 twos, 4 threes, 4 fours and 4 fives. Okay. The value which I have feeding is in decimal. Okay. Its equivalent hexadecimal number will be showed as you pass your cursor on that number. Okay. Now we shall execute the program. So very first step is, we are moving number of elements in the array to R1. We have 5 elements, that is passed to R1. Then we are decrementing that value by 1, because the number of additions performed will be equal to n minus 1, that is equal to 4. Okay. Then I am passing this R0 with my initial address. Here the initial address can be considered as per your requirement. There is no rule that you have to consider 0x470 only. You can consider any address as your initial address. Okay. I have considered this as my initial address. After passing this initial address to R0, I am storing my first element or first array element to this memory location. Okay, I have done this, and you can observe what in memory location R0 I have stored 4 times 1, which is moved to R2. Okay, so then here from memory location the value is passed to our register content R2. Then the memory location is added with plus 4. To that plus 4 location, I am passing my second array element. Then addition of my first and second array element is done, and the value is stored in R2. Okay. After that, R1, that is nothing but our counter value, is decremented by 1. So observe, R1 is equal to 3. Then it is compared with 0, that is not compared with 0, which is not equal to 0. Then loop is executed again, where next array element will be copied and it is added with the first array, first addition. Okay, this will be executed repeatedly. When R1 value becomes 0, there will be no further execution of the loop. Then our overall sum will be stored in this memory location, which can be checked in our memory window by typing the address. Press enter. Observe the R2 register. We have 4 Fs here, and you can find the same 4 Fs in our memory locations. Okay, this is all about program number 4. Thank you.